A monolithic rock is zooming toward Earth at a frightening pace. What would happen if it collided with our planet? It'd be all kinds of bad news if a giant space asteroid slammed into us. We're talking massive shockwaves, quakes, wild tsunamis, and big fires. Surviving that kind of situation would be tough, but NASA's got our back. They're already on the job to push or break up any space threats that could head our way. Join us as we uncover the thrilling details of NASA's planetary defense mission. What happens when an asteroid strikes the Earth? An asteroid collision with the surface of Earth would cause immeasurable destruction. First off, the smashing asteroid would create a giant hole. The monstrous force causing this crater would shake things up big time. It'd practically scorch everything in its path, leading to huge firestorms that'd consume cities and forests. Tsunamis would stir up earthquakes that'd tear the buildings into shreds. But the catastrophe doesn't end there. The debris and dust would block the sunlight, causing darkness to last for a long time. This blockage to sunlight would wreck the ecosystems, wiping out humanity entirely or bringing us on the doorstep of extinction. NASA's DART mission launch. DART stands for Double Asteroid Redirection Test. It made history by being the world's first showcase of asteroid deflection technology. On November 24, 2021, the mission was launched by NASA via a SpaceX rocket from California.
All right, so we're going to continue to keep an ear on things. Next thing we'll be listening for is the SpaceX launch conductor poll at T-minus 4 minutes. That's the next milestone you see.
NASA had been working on this mission for a long time. In June of 2017, NASA transitioned from the concept development of the mission to its preliminary design phase. The final assembly phase of the mission was announced in August 2018. Then, after putting everything together, on April 11, 2019, NASA revealed that a SpaceX Falcon 9 would serve as the launch vehicle for their DART mission. DART journeyed for more than 10 months until it reached its destination, Dimorphos. A petite celestial body, Dimorphos is the moon of the near-Earth asteroid 65803, Didymos. With a diameter of 177 meters, 581 feet, it forms a binary system with the Didymos. Dimorphos was the target of the DART mission. On September 26, 2022, NASA's spacecraft deliberately collided with Dimorphos to change its trajectory around Didymos. Before the impact by DART, Dimorphos was an oblate spheroid with a surface covered in rocks but no visible craters. Instruments and spacecraft used in DART. DART was put together by APL, Johns Hopkins Laboratory. The spacecraft carried a single instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, DRACO. Based on the Long-Range Reconnaissance Imager LORRI that was used on the New Horizons spacecraft, DRACO took pictures of Didymos and Dimorphos as DART approached them. It also helped the spacecraft navigate autonomously in the vast space. But that's not all. DART used several other new technologies too. APL applied its expertise in missile guidance. The small body maneuvering autonomous real-time navigation, SmartNav, algorithms enabled the spacecraft to find and maneuver to its target. In the final hours of DART's mission, SmartNav used DRACO's images to distinguish between Dimorphos and Didymos. Prepared by the Italian Space Agency, a CubeSat named Licia Cube was also hitched with the DART's craft to capture the big smash-up and all the debris that resulted from it. Moment of truth, the day NASA's planetary defense mission succeeded. The world tuned in as the historic moment finally unfolded on 26th of September 2022. NASA broadcast the triumphant success of DART's mission. The official broadcast stream captured the precise and decisive impact of the collision. People from all over the world witnessed the successful implementation of this pioneering asteroid deflection. The DART's investigation team confirmed that the spacecraft's impact on the asteroid Dimorphos successfully altered its orbit. The analysis of data gathered over the past 2 weeks since the collision provided crucial insights into the orbit change resulting from DART's impact. They've even got pictures showing the before and after effects of the spacecraft's kinetic impact. This is the momentous moment when the surface of the Dimorphos asteroid was blasted by DART. Captured by NSF's Noir Lab SOAR telescope in Chile, it shows more than 10,000 kilometers of trail of dust after the collision. This image, captured by Licia CubeCam, shows the plumes of ejecta after DART collided with the Dimorphos. The outlined rectangles you see distinguish the image's contrast level to enhance the visibility of the plumes. Impact of DART on the asteroid. After DART crashed into it, the Dimorphos went through some serious changes in its orbit and looks. The collision knocked 32 minutes off Dimorphos' orbit around Didymos, making it speedier, down to 11 hours and 23 minutes. It was the first time humans intentionally shook up a space rock's motion. The impact also produced a debris cloud that was visible from Earth-based telescopes and from NASA's Hubble and Webb space telescopes. DART's processed footage is mind-blowing. A citizen scientist, Jacint Roger Perez, provided a fresh perspective on DART's collision with his extraordinary image processing skills. He utilized the raw images of the DART's mission and converted them into a set of stabilized videos, showing a much clearer view of the spacecraft impacting the asteroid. The footage shows us all the action up close, as if it happened right in front of our eyes. Look at that crystal clear image of the blast. DART validates the theory of kinetic impact. NASA's DART mission validated the effectiveness of kinetic impact. It's now a proven method to alter the trajectory of an asteroid. 4 research papers published in the journal Nature detailed DART's successful demonstration of kinetic impactor technology and its ability to autonomously target a small asteroid. These findings will significantly contribute to the study of asteroids and comets. DART's target was not a threat to Earth. NASA has made it clear that DART's target wasn't a threat to our planet before, during, or after the mission. So, you know what? Despite speculation, the big hit from DART didn't actually shake up Dimorphos and Didymos' orbit around the Sun. The Didymos system, though classified as potentially hazardous, doesn't pose an immediate threat to Earth. Now, we don't know about other asteroids' future risks, but the Didymos system isn't really gunning for Earth right now. Analyzing data. NASA digs deep into DART's full effect. The debris cloud has changed shape over time as the material moved in space. Hubble and Webb also gave us the lowdown on what Dimorphos is made up of and what it's like on the surface. NASA has continued to collect data from radars and telescopes around the world. Right now, their main task is to figure out how efficient DART's push was when it smashed into Dimorphos at the speed of 14,000 miles per hour. They're looking into all the asteroid bits that got flung out into space. That's what we call ejecta. Understanding all this will help NASA see how effective their whole planetary defense mission is. Here's what NASA has acquired from the data so far. Nancy Chabot, DART's coordination lead from the Johns Hopkins Applied Physics Laboratory, said, DART has provided us with some intriguing data about both asteroid properties and the effectiveness of a kinetic impactor as a planetary defense technology. About 4 years from now, the European Space Agency's Hera project is geared to conduct detailed surveys of both Dimorphos and Didymos, with its sights set on the crater made by DART.
Hera is going to show us things no one's ever seen before.
DART's significance. The groundbreaking DART mission showed how a spacecraft can deliberately collide with an asteroid and alter its orbit. This gives us a sigh of relief. In case the chances of an asteroid hitting the Earth linger, no need to worry, as NASA's planetary defense mission will predict and tackle the asteroid even before it plans to hit us. Bill Nelson from NASA praised the collective collaboration and cooperation of all the space agencies involved.
It was expected to be a huge success if it only slowed the orbit by about 10 minutes. But it actually slowed it by 32 minutes.
What future does NASA's planetary defense mission hold? Approaching its 1-year milestone, DART may seem concluded, but this is just the beginning of a whole new era of planetary defense, as the pioneering planetary defense test DART has set the stage for future asteroid missions. Hera, the next big planetary defense mission, spearheaded by the European Space Agency, ESA, is set to launch in October 2024. You know, NASA established its Planetary Defense Coordination Office, PDCO, way back in 2016. They've been busy keeping tabs on any space rocks that could cause trouble for our planet. Their next big project is related to early warning, called the NEO Surveyor. It's an infrared telescope that'll spot at least 90% of the big asteroids that could spell trouble. Apart from crafting the DART mission, APL has been leading the charge in making sure NASA's ready for any cosmic curveballs. This brings us to the end of our journey with Operation DART. Make sure to like and subscribe. Stay tuned for our future adventures to space.